Hi guys, in this section we want to learn how we can define a system with a zero-pole gain form. As we know, the zero-pole gain form of the transfer function is h z p k. We have here k as a gain, z1, z2, z3 to zm as zeros of the system, and p1, p2, pn as poles of the system. If we consider that our transfer function has m0 and n poles, in this case z and p are vector. Z is equal 1 by m and p is equal y by n. Also, n and m can take a real and complex conjugate values. Now we have system H and we want to specify zeros, poles and gain of system. We must pay attention that coefficient of S must be 1. Now by factoring, we can write our equivalent expression. We have here 20 as a gain of our system. We have here 1, 0 minus 0.5 and 2 poles minus 10 and minus 2. Now we go to Matlab and define our system in Matlab. First of all, we have to define our zeros, poles and gain of system. For gain, we have 20. For 0, as you know, we have just 1 0. It's minus 0.5. And for pole, we have 2 poles minus 2 and minus 10. Semicolon. Write here system H is equal ZPK parentheses. Write here Z, P and K. Enter. As you see, we got our system 20 as our gain, 1 0 and 2 poles. We can also define MIMO systems or MIMO systems with a zero-pole gain form. Now we consider system H with 4 separated transfer functions. We have to write here all zeros together and also all poles and all gains. For H11, we don't have 0, we write here just empty brackets. For H12, we have here 1 0 minus 5. For H21, we have here an equation that the roots of equation are complex conjugate. They are 1 plus j and 1 minus j. And for H22, we don't have 0. We write here empty brackets. For poles, for H11, we have here 1 pole, 0. H12, we have here 2 poles, minus 1 and minus 1. For H21, we have here 3 poles, minus 1, minus 2 and minus 3. And H22, we have here just 0. Also for gains, for H11, we have minus 1, H12, 3, H21, 2, and for H22 also 0. Now we go to Matlab and define our MIMO system. For defining MIMO systems like SI-SO systems, we have to define first of all zeros, poles and gain. For 0, we have here braces. For h11, as you know, we don't have any 0. For h12, we have -5. We go to the next line. For h21, we have 2 complete conjugate, 1 plus j and 1 minus j. And for h22, we don't have any 0. Now we define our poles. For h11, we have 0. For h12, we have -1, -1. Next line, for h21, we have 3 poles, -1, -2, -3, and 0. And for gains, right here, k, please be careful, because our zeros and poles are cell arrays. Because of this, we have used here braces. But for gains, our gains are matrix, and we have to use here brackets. And for h11, we have -1, h12, 3, h21, 2, and h22, 0. We write here system H is equal z pk parentheses and z p and k. Enter. As you see, we got 4 separated transfer function from input 1 to output 1, h11, from input 1 to output 2, h21, from input 2 to output 1, h12, and from input 2 to output 2, h22. Okay, in the next video, we'll learn how we can define with state space form. Thank you for watching. See you guys.